Hello everyone. So we're interested in how crystal clusters form in granites. And crystal clusters in basalts are often thought to form by synesis, which is this process here, where the crystals float together and attach to each other. But synesis requires a lot of relative motion of the crystals, and some research has suggested that this should be extremely difficult to achieve in granites because the magmas are very, very viscous and have low Reynolds numbers, so turbulence should be impossible. So we set out to investigate whether these clusters do form by synesis or whether some other mechanisms such as heterogeneous nucleation here could be responsible. We focused on cave feldspar megacrysts from the Tuolumne Intrusive Complex in California. This is it here, it's a beautiful field area, and this is one of the megacrysts. As you can see, they're huge. And they're full of inclusions of plagioclase, and we're interested in how those plagioclase crystals came to be included in the megacrysts. So we did some CL to look at the zoning and some EBSD to look at the orientations of the inclusions. The CL showed that the inclusions mostly have complete concentric zoning, as you can see here, indicating that they grew freely in the melt before being included in the megacrest. And when we modelled the orientations of the crystals, we modelled the faces, and we found that in the vast majority of cases, the inclusions have a face parallel to the face of the megacrest that they attach to, indicating that the two flat surfaces came together. You can see that here, where the cluster of the plagioclase faces lines up exactly with where the cave feldspar face is. This is all strongly in support of synesis as the main clustering mechanism in these granites, which suggests that maybe the granites are more turbulent than previously thought. I'd be delighted to chat further about this, so please pop along to see my poster in the session later. Thank you very much for your attention.